Now, I did have a couple people talk to me and ask me and say, what is the follow-up class to this one? I mean, it makes sense for Java that if you're in beginning Java, the follow-up class would be Advanced Java. But what about this class? And really, the follow-up class to this one is 152.161, which is Web Application Development using ASP.NET. Because the book that we're going to use for that class teaches you ASP.NET both in VB and in C#, but I'm going to only go through the C# stuff. All right. Okay, so on page 535, Introduction to Classes, Properties, Parameterized Constructors, and Overloading. And believe it or not, that's what we covered in the program. All right, I gave you a quick little introduction to classes. You saw the properties, that was the gets and the sets, and you saw the constructor and how you could overload it and do it in different ways. So we've already talked about that stuff. All right, storing class type objects in arrays and lists. The difference between storing them in an array and storing them in a list is in this language, when you create an array has a fixed size. It can't get bigger, it can't get smaller as the program's running. A list can expand and contract as the program's running. And the last thing that's in here talks about finding classes and their responsibilities in a problem. And it's literally, it has nothing to do with a computer. It's writing stuff down on index cards, so we won't spend much time on that. What is interesting, all right, and especially those of you who are working on a can-do project for me, all right, is read that at the end of the chapter, because they show you how you can have you could have multiple forms in the same project. All right. So I don't want to read to you. So I'm going to give you, and some of you have heard this shtick before, so I'll try to keep it simple. Imagine that you have a developer who buys a plot of land, several hundred acres, and decides that, let's say it's got 100 acres, and he's going to put 100 houses on those 100 acres. Okay? And this developer, we're going to keep it real simple, is really bland. All right? His name is Jeffrey P. Bland. It's Bland Development. And what he does is he's got only one house plan. So all 100 houses are going to look the same that are going to be in this development. Now, some might have siding, some might have not siding, some might have shutters, some might be blue, but they're all going to be the same house. That one house plan that you use for all 100 of those houses, that's called the class. So when we created the employee class earlier, we said that all employees must have a name, an ID number, a department, and a position. But ideally, all of those will be different for each employee. All right? If we create 100 houses based off of that one plan, each one of those 100 houses is known as a house object. All right? The act of creating an object from a class is called instancing or instantiation. All right? And that's what they get into it here again. You can read all this stuff yourselves. Talk about blueprints, and that's kind of what they use in here too. Now, when you look at this, and the only reason I'm mentioning this to you is this is what we're going to talk about a week from today. We're going to talk about how you could actually use inheritance of classes. So, for example, if I made a class called person, and I said, you know, each person has got these properties, whatever they happen to be, a height, a weight, a whatever, it doesn't matter. Then what I could do later is I could create an employee class that was based off of a person. So a person is an employee. So an employee can do anything a person can do, and then anything we decide that an employee can do. That's what's coming up next class. All right, we talk a little bit about inheritance. So when you create a class, it's the word class followed by the name of the class. That should look familiar to you because, again, the word class and the name of the class. And it's all within curly braces. That curly brace was the beginning of the class. That curly brace was the end of the class. All right? And they go through and they mention this is called a class header, and that's all fine. You can go read that stuff if you're interested. If you're not, I guess you won't. So they have a pretty good example in the chapter. We could have done this one instead, but it's actually pretty good. They create a class called coin, and this is going to simulate a coin flip. And what they end up doing then is they create a random number that's either 0 or 1. And every time you click a button in here, if it gives a 0, it's heads. If you give a 1, it's tails. Again, it's a simulation type of thing. When you are working with object-oriented programming, which is what this is, you're doing modeling. That's what this is. All right. And he goes through line by line. Again, that's one of the reasons I like this guy and I like his books. Line by line, what's going on in here. All right. This should look pretty familiar to you because this is like the first one where we did where we said employee 1 equals new employee, because that's creating an object. So when we came in here, and we did this, that was creating an object. And that told the system the name of the object is employee. The name of the object is employee 1. It's of type employee. Since we're not providing anything in those parentheses, that means we've got to add those 4 bits of information ourselves. Then we created another employee object called employee 2, again of type employee. And since we provided it with a name and an ID number, all we had to provide was the department and the position. Then we created a third employee object, employee 3, again of type employee, and we gave it a name, and we gave it an ID number, and we gave it a department, and we gave it a position. So we didn't have to add anything to it. All right. And that's pretty much what they start going into in here. He explains it. Again, does he do it better than I do? He does it differently than I do. Okay. Once you go and you create these objects, you're able then to call the methods of the object. So they've got a mycoin.toss, just like we had. We didn't call any, and you know, we said the, like the employee 2 dot, I'm sorry, the employee 1 dot name equal. All right, well, what the heck did that do? All right, so when we came in here and we did this, all right, we're setting its name. You get that. But since we're having the word name is appearing on the right-hand side, I'm sorry, on the left-hand side of the equal sign, and we're giving it a value, what that's doing is it's saying, oh, for name, take that value that you just put in there and stuff that into our variable that's called underscore name. That's exactly what we did. And some people, there are entire books on object-oriented programming. Not on any language, but just on how to do object-oriented programming and the mindset that you have to do. All right? Because it is a little bit different way of looking at things. The good news is you have been doing it like this all semester, even if you don't realize it. When you've been creating objects and you've been throwing them on a screen, you've been working with object-oriented programming. All right? You had a text box class, and you've created text box objects based off of that text box class, for example. You've got a button class, and you created button objects based off of that button class. All right. And then they went in here, probably should have used the one from the book because they didn't screw it up. But they told you how to add the new class. They called it coin in their example, and then you had coin.cs. As I already mentioned to you, you'll notice that in coin.cs, in the actual class itself, okay, there is no GUI. It's just code. Same way we did it in the employee class that we created. All right. And then all they're doing in here is they're basically creating a coin object, and they're telling it 5 times to flip the coin. It's different than what we did, but the idea is at least are similar. Okay. All right. Jumping all the way up then to page 646 or 546, I guess it is. The author says here, hey, it's possible we've gotten used to passing things into methods, but you can pass an entire object. So I could pass an entire employee into a method. Remember, when you write a method, function, whatever, how many things can you change? 1, right? But if it's an object, you can change every part of that object. So you can pass things into objects. You can return things from objects. Okay? And I want to show you something. I'm sure that this probably won't work, even though I'm hoping it will. Let's see. What is it? There is a shortcut in here when you're doing these objects. It's something with tab. I don't remember what it is offhand. There are a whole bunch of Visual Studio shortcuts that you can use that will end up writing little snippets of code and put stuff in there for you. But if you do this and you do something like this, it won't have name, etc. You'll have to manually go in and change all that stuff. But there are shortcuts. All right, thought I'd show it to you. There's a thing out there. I'll try to remember to put it out there, but there is a cheat sheet for Visual Studio. All right, some people like to use that. But a property, you already know what they are. If I said, what's the property of a person? Well, a person has a height, they have a weight, they have a sex, etc. That kind of thing. All right? So as it says, it's data about an object. You also have methods, which are behaviors that an object can do. All right? And it says, for instance, all right, if you create a label, label has a text property. All right, so again, you have been working with this stuff, and this should look familiar to you right now when you look on the bottom here of 547. There's the constructor. There's only one field, so we're having just one constructor. So when you create a new pet, it has no name. Then you go in here, and with your get and your set, you both set the name, and then you can get the name. So if that confused you when we did it in class, take a look at the code that's, or the explanation on page 548 and a little bit on 549, because he shows you exactly what's going on. Again, we could have an entire semester on just doing object-oriented C#. So you're getting in one period what we could spend a whole semester on. All right. So you can pass an entire object in to a routine. You can return an entire thing from a routine. All right, so he creates a cell phone class. I don't know why, but he does. So you can do some stuff with those, and it's just another example. There's nothing wrong with it. The examples that he has in here, by and large, I think are really good and very well done. Then jumping to the bottom of page 556 here, he talks about parameterized constructors and overloading. All right, and it says a constructor that accepts arguments is known as a parameterized constructor. So in the example that we looked at before, remember I said that was a no arg because it doesn't accept arguments. But the other two do accept arguments, either 2 arguments or 4 arguments. So those are parameterized constructors. And you'll notice that we have public employee, public employee, public employee. If we do that, that's what's known as overloading the employee method. But then what goes in the parentheses has to be different in each one of those. So there's nothing, a string and an int, a string and an int, a string and a string. They're different every time. So that's an overloaded method. You can overload anything you want in this language. All right. There's even a lot of stuff I'm not going to talk to you about that you can do. All right, so jumping up to page 562, just want to mention this to you. And I said it before, but it's worth saying again. That when you create an array is always a fixed size in this language. That's not the way it is in JavaScript. That's not the way that it is in PHP. That is the way it is in C# and in Java. All right, arrays are created at compile time. They're what are called early binded. So that means the system has to know exactly how much room to put aside. They can't change size. Even if you have nothing in the array, it's still that size. But if you create what's called a list, lists can dynamically expand and contract as the program's running. So the advantage of creating a list is it's more versatile. If I don't know how many employees I'm going to have, all right, but I know the max will be 500, well, if I use an array, I've got to make the array of size 500. If I've only hired 2 employees, now I'm wasting 498 of those locations. But if I create a list, I can add employees as I'm going on. But you'll notice that the syntax, and it looks very similar to the stuff we looked at in Java, it looks a little bit funky. You say the word list, then in angle brackets, the type of the list. So you say that, you can have a list of ints, or a list of strings, or a list of whatever. All right, so that could be just a regular variable in here too. But then the name of it equals new list, just like you saw. But then what this really does is it's calling a constructor. So that's why you need the paren in there. And that's what the author explains here on page 563. All right. Most languages allow you to use something like a list. All right. Jumping all the way up then to 568. This is where the author talks about these CRC cards. Okay? And there's actually some good stuff in here. And I just want to mention, I'm not trying to go off here or anything, but I just want you to hear this. One of the things, the decisions that I made, right or wrong, was a few years ago, we offered 2 classes in here. One that was called Object-Oriented Systems Analysis. And after you finished that, you took Object-Oriented Systems Design. They weren't code at all, but they were, the act of trying to sit there, and you literally would get a requirements document. You'd have to convert that, not into code, but you have to basically write up some kind of a project description, etc., of what you were working on. There are a lot of people on our advisory committee that are mad that I got rid of those 2 classes. Okay, they wish they were back. But as you know, anytime you add something new, you've got to remove something the way it works here. So when I made the decision to add the iOS and the Android classes, those were the 2 that I decided to remove, or be they right or wrong. The reason I'm telling you that, though, is the rest of this chapter that starts on 568 is more along the lines of what you'd get in systems analysis and design. All right. Quite often, someone starts with a company as a programmer. And if you're a successful programmer, but you've got a good head on your shoulders, you've got a good head on your shoulders, sometimes they'll offer to make you a programmer analyst. And what that'll mean is you won't program all the time. You'll go to meetings and you'll go, oh, that sounds fun. Yeah, but it usually is a bump up in pay too. All right. And then full-fledged analysts a lot of times write very little code. All right. But if you want to know more about that, what they're talking about here is looking at something from a really high-level view and starting to break it down and say, okay, this is what we have to do, whatever it happens to be. And let's start breaking our problem down and figuring out what our domain is. In other words, what it is we're trying to solve. And that's what the author starts talking about in here. And sometimes you're given a project description, something that looks like this. And then what you do literally first is you go through it. This sounds like a stupid exercise, but it really and truly isn't. I've done this before. So you're given a set of requirements like this, and you go in and you literally underline everything in there that's a noun. Remember the old person, place, or thing? But when you're talking about nouns here, it's a person, a place, a thing, or a concept. All right? And so, we looked in here, well, Joe's Automotive Shop, that's a thing. Cars, that's a thing. Well, there's cars again. Mercedes, Porsche, those are things. Okay? You might say, well, so is a name and well, look at them. The name, the address, and the phone number, those aren't going to be things. That's going to be data. All right. So what he says is the following list, as you start going in here, this is the kind of thing that you identify. And when you notice you've got car and cars, well, you're not going to have you're not going to have a class that's called car and another one called cars. That would just be dumb. Not only that, you're not going to have a class that's called BMW and one called Mercedes and one called Porsche, those will be objects of type class. So what you're doing is you're going through your set of requirements and you're trying to ferret out what are going to be your classes, what are going to be your objects. Then you kind of run through it again, but now when you go through this, you want to say, okay, each Mercedes, each Porsche, each BMW, etc., is going to belong to a customer. Good. Each customer will have a name, an address, and a phone number. So you're breaking it down even further. All right? And that's what they're talking about doing in here. So you refine your original list. You'll find out some of them, like I mentioned, cars, car, and foreign cars all mean the same thing. All right. So these are some classes that you might have. Address, maybe, no. But BMW, no. Car, yes. Customer, yes. And when you look through this, probably the only 2 or 3 things you're going to have are like car and customer. All right. So they mention how some of them are items. So they keep crossing stuff out and crossing stuff out. All right. Some of them are objects, so they crossed out more. All right. And so what you end up with is when you look here, you've got a car class and a customer class. And a service quote class. That's it. What you're doing by doing this, though, and again, it may sound like it's a waste of time, but what happens when you do this is you're understanding your problem domain. Because if you're going to end up talking with a person from Joe's Automotive, you've got to understand how they do things. They're going to be explaining stuff to you like a mechanic or a car owner would explain things, and you want to talk to them like they're programmers. They don't want to talk to you like they're programmers because that's why they hired you. They don't care about any of that stuff. So you're learning to talk the talk, as they say. All right, so you come up and you create these. After you do that, then you say, okay, I've got these classes. How are these classes going to interconnect with one another? In other words, if I've got a car class and I've got a customer class, how are these two going to have to interact with one another? If I've got a car class and I've got a service quote class, how are those going to have to interact with one another? All right. And again, you can kind of look at this as with the stuff that those of you who are in the class with Jim, the 147 class, it's like when you create your database. All right. And then you create your tables. And you know that if you want to be able to link those tables up, you're going to have fields in common. All right, between the tables. Well, here, you're not going to talk about fields in common, but you're going to talk about what kind of methods am I going to have to do, what's going to have to be public, what's going to have to be private, etc. So that's what they discuss. They talk about the responsibilities. So they say the customer's class is going to have these 3 pieces of information. They'll have to be able to get and set those 3 pieces of information and create an object of itself. So now you can come in there and you can create a customer. Name, address, and phone number, a get set for the name, a get set for the address, a get set for the phone number. Then you do a similar thing for the car. Cars will again have 3 pieces of information, a make, a model, and a year. There's the make, model, and the year. There's our constructor. There's our get set for make, get set for model, and our get set for year. Then we have a service quote class that has 4 things. Estimated parts, estimated labor, sales tax, and total estimated charge. So they didn't even give you the whole charge here because you're just going to add those together and add the tax rate. But you see how you're building something, and it's not exactly even piecemeal the way that it's being done. All right. So as the author says here, as your design process unfolds, you'll gain a deeper understanding of the problem and ways that you can improve the design. All right. So the last thing that's discussed in here, starting on page 576. And I wish, again, this is the kind of thing the author could have easily blown this thing up into an entire chapter, but instead it's about 7 or 8 pages. All right. It says a C# project can have multiple forms. You should know that. I mean, I could come in here, and right now we've only got one form. It's called Form 1, right? There it is. But if I right mouse click, and I do it in the right place this time, and I go to Add, and I go to New Item, you'll notice that one of the things that's in here is Windows Form. So if I come through here and I just call this, I don't know, test. All right. Now it's going to create another form for me. So I'm able to, if I want to have my employee form call this form or vice versa. And think about how you might want to do that. As an example, let's suppose you're building, the rock, paper, scissors game. All right. You could have had multiple forms in there. You could have had a form that showed all this stuff, and that was you. And as soon as you made a choice, you could have brought up a very similar looking form, and that would have been the computer. Then you could have brought up another form to say who won. And then when you were done, you could have brought up another form that said the total wins, for you, the total wins for the computer, and the total ties. All right. So there's multiple ways, as always, that you could do this stuff. And that's what the author talks about. Each form has its own class and can be instantiated and displayed on the screen. Hopefully you all know this, because hopefully at least your instructor was smart enough to tell you this, but I don't know. There's a lot of stuff he forgets to tell you. But if I decide right now, I haven't done anything with this, and I decide, what did I call this test? That's a really dumb name. All right, and I should call this whatever. The time to, right now, I should right mouse click on it and choose rename, and I'm going to change it from test. Let's just say I'm going to change it to customer. All right, and I hit enter. Now it's been changed. It says you are renaming. Would you also like to perform a rename on everything that references that? Always say yes. So yes. Bless you. Now if I right mouse click and I view code, notice it changed it. If I didn't say yes before, it would have still called it test. That's a real bad thing, because once you start putting code in and you manually go in and you change the name, the system doesn't like it, because there's a bunch of files that are in some of these directories that you see in here that we don't really talk about, and those files don't get renamed when you manually rename something. So just like I told you, when you go and add something to a form, how you always go and rename your control first and then add the code to it, same kind of way in here. All right, if you decide that you want to rename a class, rename it before you put any code into it. Otherwise, you're best off just literally removing it and starting all over again. All right, so they go through the rename process, what I just showed you. I just showed you how to add a new form. And again, you might say, well, that's just simple stuff. It is. All right. Now, when you do this, this is a little harder than it is in VisualBasic.net. In VisualBasic.net, you can just say me.hide or me.close, me.show. But you can't do that here. It doesn't accept it. It doesn't understand those things. So it says in Visual Studio, you can easily switch it. Yeah, we know all that stuff. But what you have to end up doing if you want to display a form is you have to create an instance of it. And that's what they're showing you right here. This is on page 580. So it's the name of the form, or the type of the form, the name of the form equals new form. Okay, so it's a little bit more work. It's done a little bit differently. And after you've done that, in order to get it to show, you can do the show dialog. As it says, it displays the form on the screen and it gives it the focus. You can use hide, so you can hide a current form that's showing, but there is no show, so to speak, like you have in VisualBasic.net. It's much harder to do it this way, because in Visual Basic you do it by pre-written routines. Here you've got to write the stuff yourself, so it's a little bit more work. All right, so they've got, and this is a very good example. So if what I just explained to you doesn't make any sense, and I would recommend, Andrew, that you and Nick look at this. All right, but here it's creating an application with a couple forms. So they have you literally create your first one, and when you click display form, it basically hides the form you're currently showing and shows the other one. You've got to make sure, if you want to be able to bounce back and forth between different forms, that you give the user the opportunity or a way of doing that. So it says this dot close, but believe me, there's more to it than that. That'll close the current form, but notice then after you close it, then you have to create an instance of the other one, then do a show dialog on it. All right. Now you may or may not know what modal and modeless is. I don't know. Imagine right now I took what I've got on the screen here and I did a Control P. All right, maybe it won't let me do a Control P. Let's try it. We'll try it from here. Let's see. I'll bring this up. Will that let me do a Control P? No. There. That's a modal dialog box. Technically, I can't go on and do anything else. At least in Charter right here, I can't do anything until I answer that. Until I either click OK or I click Cancel. That means it's modal. It has control, so to speak, of the program until I do something with it. So I can click OK or I can click Cancel. Now it's gone away. All right, so why am I telling you that? Because when you create this stuff, you've got your choice. You can create things that are modeless or you can create things that are modal. As it says, when a modal form is displayed, no other form in the app can receive the focus until that form is closed. You can also create modeless forms, which allow the user to switch focus from one form to another while it's being displayed. All right. It says if you want to display a form in modeless fashion, you use show. It says there's another important difference between modal and modeless forms. When you call show dialog to show a modal form, control is transferred to the form. That's why you can't do anything else to it. All right. When you call show, the statements that appear after the show methods can continue to execute. All right. And you're going to hear more with this kind of stuff as you go on, more next year in other classes too. All right. That's it. The only other thing I want to tell you, because I'm finished, but the only other thing I want to tell you is, again, next week we will go over Chapter 10. We will go over an example. And Chapter 10 is on inheritance. All right. So you'll hear a lot of the same stuff. Inheritance and polymorphism. That's it.